Hi everyone, so this is question 6 from tutorial sheet 2. So the question is saying simplify the given trigonometric expressions to a single trigonometric function or a constant. So when you look at this question, the first one here, okay, A, to me the first question here, A, I don't think it was written correct, because when you try, no matter how much you can try to simplify this, you will not come to a single trigonometric function or a constant. So if this question was to be correct, it was supposed to have a plus where there's a minus here. It was supposed to be like this. If this question was to be correct, it was supposed to be like this maybe, and then this term, let me put x there, and then this term was supposed to be squared. If this is the way this question was, it would have been straightforward, because you first have to factor out this sign. When you factorize this, you have 1 plus, and then tan squared x. Then for you to simplify such an expression, you need to put into consideration the 4 identities. First this one, and then the remaining ones. This one first, sin x squared plus cos x squared is equal to 1. So when you write, you need to know this one, and then also you need to know when you divide this equation by sine, sine divided by sine, you get 1. Cos divided by cos divided by sine, you get cot squared x, which is equal to, and then this one you divide it by sine, you get the cosec, you get cosec x, like that. Then it also has to be squared. And then when you divide this sine by cos, you get tan. So sine divided by cos, you get tan, and then plus, when you divide this cos by cos, you get a 1, and then is equal to, when you divide this 1 by cos, you get sec. You get sec squared x. So these are the 3 most important trigonometric identities that you need to know, because normally you can't solve these questions here if you don't know these. So you just have to master these. Actually, you don't even have to master them, but you just need to know how to make them. So like here, you have seen that 1 plus tan squared x, 1 plus tan squared x is equal to sec squared x. So while there is 1 plus tan squared x, I'm going to put sec squared x. So I'm going to put sec squared x, and then multiplied by sine x. You see? And then this sec, we know is that it's just nothing but 1 over cos. Sorry, this was also maybe supposed to be squared. Mind you, I'm just trying to correct this question. It was wrongly asked. So if this is like this, so then if this is the case, then we're going to have something like this, sine squared x over, this sec is just 1 times it. This sec is just the same as 1 over cos squared x. So if you have such an expression, you multiply this, you are going to have you're going to have sine x over cos x. You're going to have something like this, which gives you tan. It will give you tan squared as your final answer. So it has been simplified to one trigonometric ratio. So if this is the way the question wants, this is how you can solve it. But looking at the way it was asked, I don't think it was correct that way, because no matter how much you can try to simplify that, you still find your answer. You still not find your answer. So proceed. Question B. So B is saying cos squared x minus 1. So cos squared x minus 1 is okay, let me write it here. So this is B. Try to make cos squared x minus 1 from this expression. So you can make it to say when you take this cos that side, you are going to have sine here. Sine squared x is equal to 1 minus cos squared x. So if you now change it to cos squared x minus 1, it means that you're going to have negative sine this side. In short, when you divide everything by negative 1, so you're going to have negative sine squared x is equal to cos squared x. We're going to have cos squared x minus 1. And then, meaning while there is cos squared x minus 1, I can replace with negative sine x. So in this question, where there is cos squared x minus 1, I will replace with negative sine squared x, like that. And then I'll multiply it with, so tan squared x plus 1 is here, which is just the same as sec squared x. So it's the same as sec squared x. And then sec squared x, you know to say sec squared x is so sec squared x is nothing but it's just the same as multiplying by this sine squared x with 1 over cos squared x, which will give you cos and x like this. And then this can also be written as negative tan squared x. So this is the final answer. You've expressed it in the single trigonometric identity. So let's move on to the next question. That is question so let's move on to the next question. Question C. So for question C, cos, so C is sorry for that. So C is cos z, and then plus, this is sine sine z, and then multiply by, so tan can also be written as sine z over cos z. So you multiply this, you are going to have cos z, and then plus sine squared. You're going to have sine times sine, you get sine squared z, and then this over cos z. we move on to the properties of fractions. You find the common denominator there is cos z, then 1 into cos times cos, you get your cos squared z here, and then plus cos into cos 1 times sine, you get your sine squared z, like that. Then we know that cos squared plus sine squared is here, it's just the same as 1 there. So this is just the same as 1 over cos z, which gives you sec z. So this is your answer, as simple as that. This is your answer for C. Let's move on to D. So D is also straightforward. So D since sec y minus cos y over tan, so sec y we all know today is 1 over cos, and then 1 over cos y, and then minus cos, so I'll just put over 1, and then everything here over tan y. So here we find the common denominator on top there. The common denominator is cos. So the common denominator is cos y. Then on top there you find cos into cos. It's 1 times 1, you get your 1. Then minus 1 into cos times cos, you get cos squared theta. Cos squared d, we're dealing with y now. Then everything over tan. Tan y. But we know to say tan y can also be written as sine over cos. So tan y, let me put this in brackets like that. Tan y can also be written as sine theta, so sine y over cos y. And as you can see, this cos and that cos can cancel, and then 1 minus cos squared theta is just the same as taking this cos squared theta that side, and then you remain with sine this side. It's just the same as making sine the subject of the formula, so which is going to give you here on top as sine theta is saying tan theta multiplied by sine theta. Let me just do this. So tan theta we know it to say is sine over cos. So instead of writing tan theta, I'll write sine theta over cos theta. And then this is multiplied by sine theta. Then everything over sec squared minus 1 is here. It's just the same as taking this one that side on the other side of the equal sign, meaning you are going to remain with tan squared here. It's just the same as making tan squared theta as your subject, as the subject here. So that is what you are going to have. And then from there, you know to say sorry, here I said sec is supposed to, oh, I'm here, sorry. So this is tan theta over, this is sin theta over cos theta. So sin theta over cos theta is the same as tan. So this is tan theta over tan squared theta multiplied by sine. So one tan here will cancel with that tan. So meaning you are going to have sine theta over tan theta. So if this is the case, this is just the same as dividing sine theta by tan theta can also be written as sine theta over cos theta. And then you discover that that sine and that sine you cancel. So meaning what you remain with is 1 over 1 over cos theta. When you simplify this, you find that the trig ratio you are going to remain with is just cos theta. So this is how you solve E. We move on to F. So F is cot theta. So we're dealing with F now. So we're saying cot theta and then everything over. So cot squared plus 1, cot squared plus 1 is just the same as cosec. So it's the same as cosec theta, cosec squared theta. So cot we know to say is 1 over tan, which is just the same as sine, cos over sine. So cot is cos theta over sine theta, and then everything divided by cosec is 1 over cos squared theta. Okay, so this can also be written as cos theta over sorry, this is not supposed to be 1 over cos, but 1 over sine. It's supposed to be 1 over sine theta. So this is going to be 1 over sine theta, 1 over sine squared theta, and then you discover that this sine will cancel with one sine there. So meaning you are just going to remain with cos theta. Yeah, you're just going to remain with cos theta, and then here underneath there is 1 over sine theta. Then this, when you simplify it further, you find your answer to be cos theta and then multiply by sine theta. And according to the rules of compound angles, this is just the same as so that is just the same as sine 2 theta over 2. That is it is 1. This is one way in which you can solve this. I think there is another way. And then we move on to the last part here. So the last one, G, is so 1 plus sec is 1 over cos theta, and then everything divided by sine theta, everything divided by sine theta plus sine over tan theta, or sine over cos. So we know tan theta is sine over cos. So this is over 1. Then on top there you find the common denominator and simplify everything. You find it to be 1 plus, to be cos you find it to be cos cos theta plus 1 over cos theta. This is what you are going to have. This is theta, sorry. Okay. And then everything there, this will be, this is going to give you sine plus it's going to give you sine theta cos theta and then when you find the common denominator and then find it express it into a single fraction there to be sine theta cos theta plus and then sine theta everything divided by cos theta. This is cos theta. Then you discover that that cos and that cos will cancel, meaning you are just going to remain with cos on top, cos theta, and then everything divided by, you factorize this, you are going to have sine theta outside, and then open the brackets. This is going to give you 1, it's going to give you, on top here when you factorize, when you cancel out the cos, you remain with 1 plus, you remain with cos theta plus 1. And then down here you also remain with, when you factorize you have cos theta plus 1. So now you go on to cancel that, so that you just remain with 1 over sine theta. Then we know that 1 over sine theta is nothing but cosec theta, hence simplified. So this is the end of question 6. So please don't forget to subscribe to the channel. Subscribe so that you don't miss out the videos that I'm going to be posting as time goes on. If you have any questions, you can please forward it to this WhatsApp line here. See you in the next tutorial video.